Hi, we're the team from Cal Poly. I'm Sophie Getty.
I'm Connor Delori.
I'm Matthew Titchener.
I'm Nash Levy, and we're excited to share our conceptual design review for the Floating Dragon Balloon Challenge with you.
Based on the positive feedback of our initial deployment system idea, we decided to continue with what we had originally developed. So we're going to use a linear actuator to support our node within the deployment system, and then when we're ready to drop the node, the linear actuator is going to retract the pin, allowing the node to drop through a track within the deployment system and then begin its flight. The linear actuator is going to be mounted onto the deployment system using two different clamps, and the deployment system body is going to have a bar welded to the bottom of it to maintain rigidity throughout the flight.
After our feedback on our preliminary design review, we have decided to change our node shape. We were originally creating a node that had the least amount of drag in a very aerodynamic shape. Post feedback, we have decided to change that and go for the most amount of drag, and therefore we have designed our node to have drag more on the bottom and the outside rim of the node. The node will be made out of aluminum sheet metal, which will be bent and welded together. We have already started to do some preliminary structural analysis on our node shape, which can be seen in this FEA simulation. It can be seen that the highest displacement will be at the bottom of the node post-impact, which we will use in our future design.
To engage the flight of the node, we will first deploy a pilot chute, which will spring out of the node and pull the main chute out, allowing a complete and full opening. To deploy that correctly, we have enclosed the top of the node with a rope, and then when we're ready to deploy, a servo motor will spin and wrap the rope around it, which will pull down a metal piece, allowing a hinge to open and the rope to come unclasped, and the pilot chute will be able to come out of the node.
When we submitted our PDR, we had 2 inputs and 3 outputs. Now our design has 3 inputs and 4 outputs. The inputs being battery, GPS, and the magnometer. And now the outputs will be the parafoil stepper motor, the node latch stepper motor, the parafoil deployment system, and the AAT. We'll be using an Arduino Uno now. We felt that it was necessary to use stepper motors instead of servo motors because stepper motors have a larger holding torque, and the external forces that will be acting on the system will be better suited for stepper motors.
We are excited to start prototyping and testing and eventually building our node after we receive our feedback.
Thank you so much for watching.